lined up here for us, and we'll start momentarily. Thanks again, everybody.
All right. Missy, thank you for the introduction. Welcome everybody that's joined us. This is a presentation on a hot topic we're getting these days, a lot of questions from the marketplace about processing dairy proteins, value-added dairy proteins. In this case, the technology for that is membrane filtration and spray drying. This is we have a 30-minute time slot here. We have about 20 minutes worth of material depending on the questions we get. Please put your questions into the chat space and we'll try our best to answer them. But we are trying to stay at a very high level here. Just we're getting so many basic questions out of the marketplace. We've prepared this webinar to answer those. If you have deeper questions, we're ready to answer those here if time allows, but in a more one-on-one conversation if that were the case. So we'll get started here. Again, as questions come in, my colleagues Tom Shapler and Lee Talene will jump in with any answers or commentary that they may have on this. So the very basic commercial, we don't want this to be a commercial presentation, but if you don't know Caloris, we're an equipment manufacturer, mainly in three areas: membrane filtration, evaporators and evaporation, spray drying and spray dryers. We're designing new equipment and delivering it. We're updating or optimizing existing process systems in dairy and the food industry. So that's the extent of any commercial we're going to do on Caloris here. Dairy proteins. We're Again, the questions are coming in fast, like we've never seen before. Interest in whey protein concentrate, WPC 80, have been enormous. People are asking about MPC, and it's everything to do with the price explosion that's been going on. So this quote here is by Reuters. Came out a couple of months or a month ago or so, 4 times increase in the last 3 years of skyrocketing WPC 80 prices, going from a historical 250 a pound to upwards of 9, 10, now 12 or more dollars per pound. A massive shift in the market, driven both by sports nutrition brands and these GLP-1 weight loss medications that don't seem to be a fad. They seem to be a long-term trend. So we don't, as Caloris, we're equipment manufacturers, we don't comment on long-term economic trends, but those who comment to us, if I were to summarize the opinions I'm hearing from others, nobody seems to be on their GLP-1 weight loss medications for the short term. It seems to be a big American and worldwide trend. So we took a look at the prices, right? Is this true? This is a 3-year graph of US WPC 80 prices from 2024 through May 2026. It was late last year, July, August, prices seem to be steady, and then boom, there has been an explosion in prices going up to $10 and $12 per pound now. At the same time that a lot of capacity is coming onto the market, there's been 3 or 4 new WPC 80 plants being added to the marketplace here in 2025, 26. So at the same time capacity is coming online, prices are seemingly exploding. Does the same hold true for milk protein concentrate? So yes, but not to the same degree. I'm not positioned to comment on that really. Not a food scientist. Why is milk protein concentrate not taking off like WPC is? Must be something in the casein, but not the fact is the trend is there, just not to the same degree. So what does it take to process this stuff? We put a couple of slides together here on what processing technologies are used to make WPC and MPC 80 powder. If you're starting with raw milk, and you're trying to make WPC 80 powder, that's cheese making there. That's also referred to as a biological separation process. If I don't mean, I love cheese, I don't mean to denigrate cheese making. It's a science and a technology all to itself. But if your goal is WPC 80 powder, you have to go through the cheese making process to get the biological separation to make cheese and liquid sweet whey. clarifying the way to remove any final fat, and then you apply these two technologies of membrane filtration to make whey permeate and get the protein, and then you spray dry the protein and get WPC80 powder. A little bit more simplified if your end goal is to make milk protein concentrate 80 powder. So again, 80% protein isolate. Um, Skipping the cheese making, you're just separating the milk into skim milk and butter fat. The butter fat becoming butter or anhydrous milk fat, creating a skim milk. That then goes through a filtration step where you're now getting milk permeate. The casein is still in the protein. You're drying that and now getting MPC, so milk protein concentrate 80. Going to go into a little bit of a mass balance next, but inviting my colleagues to comment on anything, either on the trends or what they're seeing here.
No, Jim, I think you're highly correct. I've just been a couple of seminars, and the trend has been for less than 10 grams of protein in the past, but the acceleration now is 25 to 40 grams of protein in final products, which means the milk proteins or whey proteins. It seems to be everybody's talking more and more of that trend. Every data point you see is the trend is upping more protein coming out of products rather than just straight dairy products.
Yeah, so Lee, you were just at the membrane conference. Was that in Minneapolis? And you're saying you're hearing that out of the presentations there, that it's beverages that had an extra what'd you say, 8 or 9 grams of added protein are now 20 and 25 added grams of protein?
Yep, that's the big growing market right now. Anything from sport drinks, yogurts, even cottage cheese. They're trying to put it into everything again to satisfy the weight loss that we're seeing
Yeah,
accelerating.
yeah, I mean, I'm hearing the word protein maxing from maybe more from a younger crowd than my crowd, but protein maxing is definitely out there in social media.
Well, it's working its way into everything. I think I saw the other day Doritos with added protein, so I think if you can if they're doing it there, it's going to be everywhere.
Yeah, if PepsiCo is doing it in the Frito-Lay and Dorito products, it's
Yeah.
going to be everywhere. Um, you know, oh, we know that the whey protein has a in the beverages at least that it has a greater attraction. It's the one protein that goes into a clear solution. So that's the attractiveness of the whey protein. It can go into a clear beverage. You can have, a clear vitamin water or something like that with whey in it where it stays clear. Where if you have plant proteins or the casein protein from milk protein, the beverages aren't clear, but it goes great into a food product or a yogurt or something like that. So. Um, all right, I'll keep moving. I'm Missy. I'm looking for hands or questions, but I'm not seeing any. So I'm going to keep moving without answering anything. I'm sure you'll jump in if we've got any questions. So we took a look at this. We said, how would this be interesting to look at for people? What are people asking us about? And we said, well, everybody talks about 1 million pounds of raw milk, right? Does my factory process 1 million pounds of raw milk a day? Am I processing 4 million pounds of raw milk a day? So we use the unit of 1 million pounds of raw milk. So raw milk's at 12% total solids. So that's a breakdown there in the box. 877,000 pounds of water in that 1 million pounds of raw milk, an amount of lactose and ash. For those that aren't familiar, the ash is the calcium and the vitamins, riboflavin and the other B vitamins and the like. It has an amount of butterfat, and it has its two types of protein, casein protein and whey protein. Again, for those of you that may have joined that have a deeper understanding of these things, for this broad case, we've used some very round numbers here, just to ease the conversation. Depending on the cheese making you do, depending on the content or the breed of cow your milk comes from, these numbers may vary slightly, but we've taken a very high level view with some very broad brush numbers just to explain the concepts. So in this case, we want to follow the WPC through, or the making of this raw milk into WPC80 powder. So the milk goes into a cheese vat, however much you have per day. And if we do a mass balance coming out of the cheese vat, out of that million pounds of raw milk, you're going to get about 101,000 pounds of cheese. If you follow the butter fat through, most of the fat goes into the cheese. Essentially, in the simplified model, all the casein protein goes through to the cheese, zero of the whey protein goes through to the cheese, and a small portion of the lactose and ash go through. So that's making an aggregate of those type of American cheeses, cheddar cheese, and the like that get produced here in North America. From that, you have whey. Um, and we're just about the rest. That's where the rest of it all goes, right? This is a mass balance, so we're trying to get these things to add up. Um, Most of the water going with the whey, now it's lower solids because the solids have come out into the cheese. A little bit of butterfat carries over. Again, now we've got none of the casein protein, all the whey protein, and a lot of the lactose and ash carrying over into the whey. For those that are absolutely eagle-eyed, looking at these mass balance numbers or taking screenshots, I do have 2,450 pounds of butter fat shown on this slide. There is a clarification step of the whey because if I go to my next slide, I'm going to drop right down to 450 pounds of butter fat, presuming that that clarification step has gone on for the whey. So a little bit of butter fat gets skimmed out of the whey so that it can go into the membranes without any mechanical problems, any membrane cleaning problems going on there. But we're going to put this whey through a separation step. That's going to require some additional water, diafiltration water, to get the proteins moving or the smaller molecules moving through the membranes, the larger molecules being retained on the membranes, producing a retentate. That's where our protein's going. That's the valuable stream here in our example, and a permeate stream, what goes through the membrane, what permeates the membrane. Again, mass balance here. We're getting nominally for this model of cheese that we have here, 34,000 pounds of now WPC, whey protein concentrate. That's 80% protein. In this model, it's coming through at just about 28% total solids. And you can see that we've got most of the whey protein there. So 7,700 pounds of the 8,000 pounds of whey protein concentrated into the retained portion, the retentate. Most of everything else is permeating through the membranes, therefore whey permeates. 950,000 pounds of that because we're adding the water into it from the diafiltration water. We've got 900,000 pounds of water, a little bit of whey protein, and most of the lactose and ash carrying through. Lee, you're our membrane expert. Anything else you want to share about either your experience or things I'm missing here saying about
No,
processing whey
no,
through
Jim,
membranes?
you've given them again a broad overview. Numbers can change depending on what kind of solids you're looking for, but this is kind of a basic design, a broad overview. The two things to remember: any membrane system you have, whether it's MF all the way up to RO, there's always going to be two streams. The stream you want here is retentate, and you're going to have to deal with the permeate. There's always whether you can build systems from here all the way. I live in central Wisconsin, build them up to Minneapolis. There's always going to be a second stream. So always keep that in mind. If you can use both streams, great. But the retentate or the protein is the market is so big now that it can drive taking care of the permeate.
Yep. Thanks, Lee.
Which is significant. I mean, I think everyone's noticed that the permeate stream is more than the whey stream that you started with, right? Due to the defiltration water.
Yep. And I think, Lee, am I correct to say, right, the latest, best technology, you can put more filtration. You were saying you can put filtration in from Marshfield, Wisconsin to Minneapolis, right? You can put in more filtration and start getting up to what's the modern limit, 36% solids, but you're going to need even more diafiltration water used than we're indicating here.
Yeah, I agree. You get to a certain point where I'm a membrane guy. Be nice to sell your membranes and system, but where you're just not going to get any more bang for your buck. You've just driven as much as you can. A long time ago, we wouldn't even be thinking about the solids we are now. It may change, but I think right now, because I work for a memory manufacturer. I don't know we can drive it any higher with conventional. There are always new items coming up. So maybe we can get higher with other techniques. But now that's about where we want to go.
Yeah. And what we're going to show you next is that this product, this retentate, where we have our 80% protein concentrate at this 28%, or if you were to put more filtration in and go higher, upward towards 36%, it makes sense to go directly to the spray dryer. We're not skipping over the falling film evaporator step. It's just generally not applied. We're at a high enough solids where even though Caloris is known in the marketplace as an evaporation company, it just doesn't make sense to put an evaporation step in, you can scientifically do it, but economically to add another unit operation just doesn't make sense to most customers.
You just can't get the solids that much higher enough to justify the
Right.
additional expense.
Yeah, Tom, would it be right to say,
anyway?
Tom, would it be right to say, even if the membranes got to 36%, maybe you could get to 38% in an evaporator, and that's just not worth the stainless steel
With WPC 80, you could hardly get anything more in an
than the
evaporator.
36. All right. I'm going to move ahead. We're now going to take this retentate. We're going to follow the retentate stream. I wanted to comment as well with different filtration arrangements, right? We're doing an example here today of WPC 80. You can do another standard is whey protein concentrate at 60% protein. There's whey protein isolate that's sort of 90% protein, maybe a tiny bit higher than that. You could do examples like this of milk protein concentrate. And milk protein concentrate, I'm not saying it's the wild west of technology, but then you're starting to make tailored products. There's not these benchmark standards. You might make MPC 60 or 70 or 80 or 85% protein, or milk protein isolate at 90 or 92% protein. So you can in the milk protein concentrate world, you can create your own custom product depending on what the processor's end customer might need. So with that, I'm going to follow the retentate stream on to the next slide, and take this to a spray dryer. So again, same numbers as the slide before, no changes. 34,000 pounds of our original million, right? This example is starting with 1,000,000 pounds of raw milk, whether you have that in a day or you have it in an hour. We're just following 1,000,000 pounds of raw milk through. We get 34,000 pounds of WPC liquid concentrate at about 28% solids, a lot of water. We're following what started as 8,000 pounds of whey protein in our 1,000,000 pounds. Sorry. We're still at our 7,700 pounds captured. We're going to put that into the spray dryer. We're going to spray dry it in air. We're going to evaporate 24,000 pounds, a little more than 24,000 pounds of water. And we're going to finish with a little over 9,800 pounds of WPC 80 powder. 80% protein, 20% other things, a little bit of fat, a little bit of lactose, a little bit of calcium, and the other remaining ingredients, and 7,700 pounds of the whey protein. So that's now a powder at 4.2% moisture, right? Is it 4? Some people want 5. It can all be tailored in the spray dryer, so you're selling as much water as possible. I'm just trying to make my mass balance work here. So spray drying this, again, same spray dryer can be used for a whole lot of products. You can tailor the characteristics of the powder. I'm showing in my graphic here a multi-stage dryer that might make agglomerated powder, instantized powder. This would go into consumer products where maybe you're buying a powder at Costco that's a protein additive and you want to put it in your smoothie in the morning. So you scoop the powder from the big container into your smoothie. You need that to dissolve well. In that case, a processor might be agglomerating or instantizing the product. If the processor is selling their WPC 80 to another business company, right? So another industrial company, somebody making a beverage, and then they sell that beverage, right? Then you don't need these agglomerated and instantized characteristics, and you could have a bit of a simpler spray dryer. So there's, again, some characteristics of the spray dryer that come to if you're selling a direct-to-consumer product or if you're selling a business-to-business version of your protein concentrate powder. So go to a bit of the last slide here from us. Um, Multi-stage dryer I'm showing here. Again, a multi-stage dryer can be used for many, many proteins. We talked on 2 slides ago about all of the milk protein concentrates. You have once you have the spray dryer, you can do many things with a multi-stage spray dryer. Again, the agglomerated products, the instantized products for a direct-to-consumer type powder where it's mixed in the home environment. You can use it for varying degrees of whey protein, including whey protein isolate, the various milk proteins, milk protein isolate, same spray dryer, taking advantages of changes in the economics of the marketplace. What are they paying? What is the market paying for the powders you might make or produce? And if you look into a long future, a spray dryer is a 30, 40, 50-year investment. What if the future changes? Well, that same spray dryer is very well suited for making non-fat dry milk. So that's the USDA standard of non-fat dry milk. It can make skim milk powder. At a basic level, that's not very different from non-fat dry milk, but it does have a different standard of identity. The Codex standard for a standard amount of protein in that skim milk powder. The same dryer can be doing whole milk powder. In other parts of the world, it might be doing cream powder. And then you can venture further than that with infant formula base powders that get custom blended later. Other nutritional formulas might be sports nutrition, might be geriatric nutrition, might be medical nutrition formulas, medical delivery formulas where a drug supplement is mixed in for I don't know, osteoporosis, cholesterol, and the like. So nutritional formulas are a very broad category these days, or nutritional formula bases. So again, once you have that spray dryer, you're thinking WPC 80 today, that same spray dryer has a lot of possibilities in the long future. So with that, we're about 25 minutes into our 30-minute presentation here. Tom, anything else you might think you want to add?
No, just to revisit the points from before, I guess to drive home, a couple key considerations in this whole idea of how to capitalize on the presence of proteins, that you may have access to, is that you generate a lot of permeate. It may require quite a bit of difiltration water, and you've got to deal with that permeate somehow. Of all the products that Jim just listed that you can dry on that dryer, the one product that's probably not great, the protein dryer is probably not well suited for, is drying permeate. If anybody knows, what all goes into drying permeate, and you got to have an outlet for the permeate one way or another, whether it's to dry it or to dispose of it otherwise. So that's a big consideration.
Yeah, thanks, Tom. Thanks for punctuating that that remark, right? If we've said it a couple of times, it's the question that keeps coming up. I'd love to, from a processor, I'd love to make money on my protein. That's the value stream. That's the gold out of the gold mine. But you've got a lot of rock, you got a lot of ore coming out of your mine, and something has to be done with that. So that's the permeate stream. That's the lactose and sugar in the permeate stream, all the water. There needs to be, you as a processor need to have an economic plan for dealing with that amount of that product. In some cases, it goes back to the farms. It's a lot of product to field spread. And it has a cost to process into its own powder, which is a simple commodity and doesn't yield much economic return out of it. So, no, Tom, thanks for punctuating that again. Lee, any final remarks you want to leave the audience with?
No, I mean, Tom brought up the permeate. Again, there are thousands of these systems around worldwide, and the permeate is going to be the issue, but the driver is the protein. So on the permeate side, we can use an RO to concentrate it, or use an RO and evaporator, or straight evaporator. So there's ways you want to remove as much water from the permeate as you can. And maybe they can't capture some of that water and reuse it for difiltration and for CIP of the UF. So there are ways to use the permeate for other issues and use the water back into the plant to save water usage, because the UF will use quite a bit of water. That's just one note. It is what a UF is. It's a very open membrane. It allows the retentate or rejection to allow proteins to pass through and keep the permeate on the other side. But it does use a lot of water when you're going to turn it around and CIP it. So a way to capture water is something that Caloris has done for years. So there's another way to get that taken care of as well.
All right, Lee, thanks for that. For our attendees, thanks for attending. We're going to stay on for a couple of minutes if the questions come. Again, as Missy said at the beginning, the presentation will be online. Our email addresses are here on the final slide. You should feel free to reach out to us or on the Caloris website. With that, I'm going to say thank you very much, everyone, for your interest. And Missy, I'll let you make any closing remarks.
Yeah, I haven't seen any questions coming in the chat, but please feel free to enter any if you have them. Jim, if you wouldn't mind stopping sharing, I have one image to share while we close things up. And I do have a question that occurred to me. Say I'm working for a typical dairy and we haven't explored dairy proteins until now. What does that initial fact-finding interaction look like between Caloris and my facility? What information do you need from me? How do we get the ball rolling, I guess, is the question.
Uh, good question, Missy. Right? It's a telephone conversation. If we're nearby, it's an in-person conversation. We need to know the volumes you're trying to produce. We need to know a little bit about where it's coming from, especially if it's whey. You have a cheese making process. There are some wheys that are unsuitable to process. And Lee, maybe you can comment on all of the acidic type wheys where it's not appropriate to process them onward and capture the protein. But that next touch, if you are interested in having that next conversation, it's a half an hour on Teams. It's where you are thinking of doing this in the world and what your volumes are is really the very first parts of a conversation.
Yeah, and I would add, like Jim said, the streams that come to mind are cottage cheese, which is an acid whey. We're talking typically sweet whey. There have been some ventures into acid whey proteins. They have a bitter flavor to them, or bitter. There's some ways to do it, but it's mostly sweet whey. The other one is ricotta whey, because ricotta, again, I'm not a cheesemaker, but ricotta retains a lot of the protein. So if you're trying to capture that whey and get protein out of it, it's really not a very good venture because there's just not a lot of protein to get there. The other thing, ricotta has a lot of small fines that really are difficult to get out of, and a spiral membrane does not like those small fines. So I'm open to suggestions about it, but so far ricotta has not been. We've done sweet whey to enhance ricotta whey, but ricotta whey itself is not a venture. And again, the acid whey, I know one of the yogurt manufacturers, they take that acid whey and they RO it just to concentrate it and send it out of the animal feed. They're not trying to capture any of the proteins.
Another question, if a existing facility is looking to pursue this as an avenue, are they looking at a lot of new equipment? Are they looking at some of their existing equipment generally being able to be retrofitted or adjusted to do this? What's the typical scenario look like?
Missy, good question. As my first reaction is, oh, they better be ready for a lot of new equipment, right? Because we're the guys that sell equipment. But no, the reality is I'll let Lee speak in a moment to what retrofitting specific membranes into maybe an existing membrane system might look like, or restreaming a filtration system, a factory with an existing spray dryer. There are ways to utilize some of the existing capacity a plant may have and repurpose a spray dryer. Now, when you touch existing equipment and repurpose it, renovate it, whatever, Often modern codes come into play. And when you have that 20, 30-year-old spray dryer that maybe is not meeting modern safety codes for explosion protection and over temperature or fire protection, touching the dryer and putting a different product on it may have significant impact on what you can really do with that dryer from a modern code standpoint. So, Lee, comments on what it means to repurpose membrane filtration?
Yeah, I mean, the early market a long time ago, majority of people were making 35 or 50% WPC, and those are great. Those units can still be used. When you're making 80, the front half is still very similar to making 35 or 50. So just to add on, yeah, obviously more filtration equipment. You might have to look at line sizes and some of the tank sizes for it. But if you've got an existing UF or even in some cases RO converted to a UF, that's a bit more difficult. But if you have an existing UF, expanding it is not, it's just more footprint. And usually filtration size of footprint and what you have is not that great versus, the evaporator and spray dryers take a lot more area needed. So yes, it's an easy conversion. It's a conversion that you would start with the basics anyway. So it's all there.
And we have the resources available to help folks work out the return on investment outlook on either changes to their existing lines or new additions. Correct?
Yes. I mean,
You said it so matter-of-factly, Missy, we thought you were making a statement there. Yes, that is exactly correct.
Okay.
Part of an initial conversation can be coming to evaluate what you have, having an honest and forthright talk about the process, the reutilization of equipment, the space that's available on site, the utilities that are required, so that whether again repurposing a building on an existing site or building something new, you can have a meaningful dive into your own analysis of what the requirements might look like, both for processing risk and costs and business risk to your company.
Similar on the filtration side, when it gets further into depth, we'll provide water usage, steam usage, horsepower, everything that you should need to understand if your infrastructure can handle it or what you might need to expand with. That all comes with, when we get a certain part of the package, we start early, we can give you some of the basic details, but as it gets further in, we'll give you more down to earth details that will affect your plant.
All right. Well, with that, I think we should close things out. You can feel free to send follow-up questions to any of our presenters or to info@caloris.com, which goes directly to me, and I'll share it with the appropriate team member. And we would welcome any suggested topics for future webinars you would like to see. You can also send those ideas to info@caloris.com. And again, this webinar and all of our past webinars are available on caloris.com/caloris-webinars. Thank you, everybody, and hope to see you on a future webinar.